Welcome back to my class. Let's start the Algebra 2, okay? And let's talk about the inverse function because we are going to do the absolute value inverse function today. So before we do the absolute value inverse function, let's refresh our memory about doing the inverse function. If we have a simple one like this, y equals to 3x plus 5. If we want to get this guy's inverse, we will change the y to x, and we will change the x to y. And then we can move around, minus 5 to the other side. So x minus 5 becomes to 3y. And then you divide by 3, so y is 1/3 x minus 5. If you want to write down the inverse, you just write down f inverse x equals to this. That's simple. But if we have a function like this, and we want to do the inverse, it's going to be a little bit complicated, but we still can do it. So let's try here. Alice, please unmute yourself. Let's do this one together. Go ahead. How do you do this guy's inverse?
Number 1.
Step 1, you want to change y to who? You want to make y to x, right?
Yeah.
Go ahead. Make yourself a little bit louder. I have trouble to hear you. So you make y to x, and you make x to y. Yes?
Yeah.
Okay. And then?
Y plus 5.
Yeah, good job. And then we will, because we are doing the inverse, so we switch y to x, x to y first. That's the first step. And then we are going to do the multiplication to the other side to solve the y. Go ahead, please. Go ahead, please. So you will do the x times y plus, go, 5 times x, right? Yes.
Oh, equals y minus 3.
Thank you. And we are solving the y. Let's move around. We can move the y to the other side, or we can move this to this side. Make the -3 to the other side. Whichever you prefer. Go ahead, please. You can move the 3 to this side. You can move this guy to this side to solve the y. So you can do 5x plus 3 equals y minus xy. So far, so good?
Yeah.
Okay, we are solving the inverse function right now. And then we take out who on the right? Who is, y is a common factor, right? So 1 minus x. So far, so good? So y will be how much?
5x plus 3 over 1 minus x.
Excellent. So you have 5x plus 3 over 1 minus x. Okay? And then you can see here, this guy and this guy are the same, because you can put a negative here and you can flip this to be x minus 1. Yeah? You agree? That's the same. Okay? Yeah.
Okay.
And you can solve the y already because you flip the y to x and you solve the y. So this is going to be exactly the inverse function you are looking for. Okay? Yeah. I believe the school is going to do the inverse function very soon. Yeah. So yeah, so this is the foundation for doing the inverse function. And then we are going to do the major thing for today, because this is a hard part. Not hard, but it's very confusing. So I'm going to explain here. Let me call another student. See, Lucas, let's try here. You see this guy. This is called what?
The
absolute value.
Yeah.
Okay,
Yeah,
this is called absolute value. So when we do the absolute value, we will find out this guy's inverse function. The previous question, look, I want to talk about the even and odd functions. For y equals 2x minus 3, this kind of thing. It's a simple one. When you want to do the inverse function, as long as you do a reflection over the y equals to x, you will be able to have the purple line reflect over the black line. You have the inverse function. The original function and the inverse is reflected over y equals to x. But if you have the absolute value, when you do the inverse function, it's not going to be so easy, okay? So why? It is because the absolute value one is not one-to-one. It's, see here, it has some, you do the here, absolute value x plus 6. You see this one, okay? This one. This one, you can have a constant y value, but you have the 2x value. For this kind of thing, when you do the inverse function, it's going to be very tricky. Oh, by the way, Benjamin, Shunlang, all open your video camera. All the students, unless you are in a car, otherwise you have to open the video camera during my class. Thank you. So we have this guy here, y equals this. And we want to look up, watch out here. Listen, if your school has this part, this is the part students lose points easily. You write down y equals to this first. As we did just now, we do the inverse. So first step, we do the inverse. We change the y to x. And then x to y. So far, so good? Yeah, this is the first step to do the inverse, Lucas, okay? So you change y to x, you change x to y. This is the first step. But second step here, when we want to get rid of this, we want to take off this jacket, we have to put the restriction. So you have to put the scenario 1. You make the inner one greater than equal than 0. When this guy is greater than equal than 0, how much is this? If I say this y plus 6 is positive, you put this absolute value, this should equal to, Lucas. If this is greater than equal than 0, you put the absolute value, this equals to what? The guy inside is positive. Negative. No, the guy inside here is positive or equal 0. So you can get rid of the jacket directly. Yes? If, say here, this equals to A if A is greater than 0. This equals negative A if A is less than 0. 0 can be here, because positive 0, negative 0 are all 0. Okay? So if the guy is positive, you get rid of the jacket. This is y plus 6. Okay? Yeah. And then you have, say, with this restriction, y is greater than equal than negative 6. You have x equals to negative of this, which is negative y minus 6. So far, so good? Yes. So you can rewrite this. Yeah, you can say, oh, I'm going to make the negative y to the other side, which is positive y. I'm going to make the x to the other side, which is negative x. So this guy becomes to this guy. If you say, I'm not able to do so fast, that's fine. You can say, first you plus y for both sides. Negative y plus y is 0. So you have this. And then you minus x to the other side. So that's how you get it from here to here. Okay? This guy is your inverse function. You switch the y to x, x to y. You solve your y. So the solved y result is your inverse. But we have to be careful. You cannot just say, hey, my inverse is always this, which is not true. Because look, we already said for the original function and its inverse function, it's going to be reflected over y equals to x. So if you check it, if you say, I'm going to make y equals to negative x minus 6. See, this blue line, the original purple one, is my original function. And the one I solved is this red line. These two are not exactly reflected over the y equals to x. It is because you had to put the restriction. Look at here. Say one more time. The thing we put, the reason we can write down that guy equals that guy is because we make this guy greater than equals than 0. The y here is greater than equals than negative 6. This is the original function. Here is the inverse function. The original function is y, is the inverse function is x. The original function is x, is the inverse function is y. So for that guy in the inverse part, y is greater than equals than negative 6 means the original one is greater than equals than negative 6. So you have to put this restriction so that your teacher will count your work here as correct. If you don't have this thing, probably take off all the points. How do we put the restriction in the graphing part? You will do a curly brackets. You will make your x greater than equal than negative 6. And then after that, you will see this guy here, right? This red and this purple is going to be reflected over the y equals to x. You see here? Now they are reflected. Okay? After you put the correct restriction, it's going to work. I believe students still feel confused. If you have trouble, just unmute yourself. I will walk through with you. Any questions so far up to here? Any questions so far? Lucas, you can mute yourself. Thank you. Hey, Audrey Huang?
Yes.
Okay. So we are doing the absolute value functions inverse function over here. Okay? Yeah. And because the previous easy function is a linear one, it has one x corresponding to one y. For this thing, when you do the inverse, it's simple. As long as you do the reflection over the y equals x, that's easy.
Okay.
But when you have something like a parabola, when you do this parabola, when you want to do this guy's inverse function, it's not so that simple. Because this guy is not one x corresponding to one y. Here, the one y value corresponding to 2x. So when we do this kind of scenario, we have to put into two different categories. Category 1, you restrict the guy inside to be greater than equal than 0. Category 2, you will restrict this guy less than equal than 0.
Okay.
Algebra 2 AAC. First semester, your guys will also have the parabolas inverse function, something like that. So when you do the inverse function, we have to keep in mind, this top trend has inverse function with this one. That guy is that guy. So let me draw here. I want to make sure students truly understand what we are doing here. So you have a parabola like this. If you want to do an inverse function looks like this. But you cannot say, hey, this guy inverse is this. That's wrong. You have to say, when your x is less than this value, and the corresponding inverse function is that part. So you have to put the restriction. if your original function fx is this part, then the corresponding inverse function is that part. If we don't put the correct restriction, some people, if you give the result, say this guy is this guy's inverse, wrong. This guy is this guy's inverse, wrong. For the absolute value function, same. If you have absolute function like this, okay, if you have absolute value function like this, when you do this guy's inverse function, the inverse guy is going to looks like that. Okay, so you have to also put the restriction. If you say, oh, when your x is less than this value, then the corresponding inverse is going to be this lower one. When you have your original function, x is greater than this value, which is the right part. And then the corresponding inverse is going to be that part. Okay?
Okay.
So this is a true story. This is a true story, but we have to show the work. The work itself is not hard, but it's very confusing. So just now, I asked Lucas did this part. And now, Audrey, I want you to do this second part. So we have that guy, yeah? We are going to solve the y. We are going to solve the y. So let's go here. We make the guy inside less than equal than 0. Okay. So if this is less than equal than 0, then negative of y plus 6. Okay. Yeah, don't answer too quick. Let's think. That guy is a negative. And you put the absolute value. And you put another negative in front. So this should equal to who? The guy here is a negative. You have this jacket. And outside you have a negative. This guy should equal to
who? Negative parentheses y plus 6.
The guy here, look, first, the thing here is negative, yeah? First, this thing is negative. So you say, suppose the inside is a negative 3. You want to get rid of this. This is positive 3, right?
Yeah.
Right. So if that guy, this equals to negative y plus 6. Yes?
Yeah.
And I have a negative here. So I have a negative here. So this is positive. Okay. Make sense?
Yeah.
So this is negative this equals positive this. Okay. So far, so good.
Yeah.
All right. Now, with that restriction, that part equals this. So we will say, oh, if y is less than equal than negative 6, then the x is equals to negative, which Audrey already did here, which is y plus 6. Okay? Okay. So that is our inverse function. That is our inverse function. But if you don't put the restriction, many teachers, boom, just count you as wrong. The guy is true when you satisfied that condition. This guy is true when this is true. Without this, this is not true. So we have to put the original function, copy down the original one back here. And the y for this inverse function is my original function's x. So I should put x is less than equal than negative 6. So we will have the purple parts. We will have the blue parts. Does anyone have a question? in your school, the teacher will grade your work based on, look, if your school teacher graded this part, school teacher check, did you switch the Y and X? Okay. And then, did you put two different scenarios talking about the guy here is positive or negative? Did you show these two steps? And then, next, did you really show this thing correct? This is the grading parts. They check mark this to give you the point. And then after that, did you solve your Y so that you can drag your inverse here? Did you solve this part correct? And last part, did you have the restriction marked here? If not, sorry, a lot of points taken off. Because if you don't put the correct restriction, how do you guarantee that this guy is exactly corresponding to this guy? That guy is corresponding to that guy. This and this is not inverse at all. That is inverse, reflected over y equals x. That is reflected over y equals x. Same thing in the future when you learn the parabola. Maybe you have same issue. This part is a little bit confusing, but if you truly understand this part, when we come to the parabola inverse, you will feel, oh, it's old story. The same thing we are going to drill in here in the future is going to be same. We need to show this step. Number 14. I will do this. I will let you guys to fill in the blanks. Okay. If I let you do from the beginning without showing anything, that's too much. But I'm going to let you guys fill in the blank. Go ahead. Do this 14 on your own paper. When I see most kids get this, we can move to some question more complicated with more vertical stretch and vertical shift. Okay, go to number 14. Algebra 2 AEC is even more than triple amount of the work of Algebra 2 regular class. But without Algebra 2 AEC, we cannot learn pre-calculus. Any students, if you think this is too much for me, I don't get it, you can unmute yourself. I will walk through with you. Don't feel shy, okay? You come to my class for asking help.
木星老师
Yes.
I came in late, I think. So like I missed part
Okay.
of the class. I didn't really
Sure.
see it.
Sure, we are solving the inverse function right now. The
Okay.
absolute value inverse function. Previously, we are doing those simple one like y equals to 2x plus 1. Yeah, you switch
Yes.
y to x, you switch x to y. And then you solve your y. So y is x minus 1 over 2. Yeah, so those things is because the linear function 1x corresponding to 1y, 1y corresponding to 1x. Those things are easy. But when we have something like that thing, or that thing, when we do the inverse function, we have to match. We have to make sure it's going to be paired. Like what I show you guys here. This guy is absolute value function. It can opening up, it can opening down. If it's opening up, the inverse function, you cannot just say, oh, the inverse function is something like this. Number one, this is not a function. It fails the vertical line test, right? Number two, the guy of this line is symmetric of this with y equals to x. Why? Because your original function is this. What you did for the inverse, you switch your x, y value. So, of course, the original function has a symmetric with the inverse by y equals to x. So we are doing here is going to do the restriction. If you say, okay, your fx equals to that, and then you will show your x less than equal than this value, less than this value, so that inverse is going to be this. That's what we are showing right here. Right here. First, we will make this guy inside positive. And then you get rid of the absolute value. So the positive guy, absolute value, is that guy itself. And then you have x equals to negative this. And then you move around, you have your y. You solve this y. But this one, you know that this is a negative x minus 6 is going down, is this. Yeah, it's this. It's this part. The original one here is going to be like this. So this guy will not be the inverse for these two parts. No, that's not possible. This guy is only the reflection part of this part only. So we have to show the restriction over here. That's, see here, that's this part. You make first, you make this guy greater than equal than 0. And then the guy inside is positive. You get rid of the jacket, it's this. And then you can say, if this is positive, so your y is greater than equal than negative 6. When you solve it, so your x is, the x is that part. Yeah, you make this guy equal this guy, and you have a negative in front. So you have here. And you solve your y equals this. Okay?
Okay.
And that is your inverse function. But you cannot just say this is inverse function. That's incomplete. You have to show the guy here. Why you put x? This is your inverse function. The inverse one's y is the original one's x. So that's what you have here. If you don't have this part, that thing is not valid. The guy is true when this is true. So you have to show this part as your homework. Okay? Yeah.
Like where do I get the restriction from?
Restriction is from here. When you want to get rid of the jacket, you have to talk about the inside is a positive or negative.
Oh, okay.
I'm waiting for a student to say, oh, last year your sister learned this with me. She has the same question and then she say, oh, I know she got it. Makes sense?
Yeah, thank you.
Good. Any other question? I want you guys do it. Do this. This class is, look, this is a thing I teach. Before this class, I teach kids this thing. This thing is really complicated. It's horrible. One question takes many steps. All those things are based on what we have learned so far. These are all important foundations. Any people send me your work? You know, we have some very smart kids. Send me your work. Alice, you finished?
I'm almost done.
Almost done. Good. Lydia, Audrey.
I'm still figuring it out.
Okay. If you have any step you need help, let me know.
Okay.
Teacher,
Yes.
after you reverse it, what is the restriction? Like, how do you solve for it?
Okay. Yeah. Good. I'm glad you asked me. So we first talk about the guy inside this. It could be positive. It could be negative. When it's positive, you can get rid of this jacket. Because the guy inside as a positive, you can just get rid of the jacket. And you have the guy here, which is greater than equals than 0. So your y is greater than equals than -6. But this is a y. This is the inverse function's y, which is the original function's x, because you switch the xy here. Yeah. So the guy here is going to be the original function's restriction right here. You have the y here, you solve it greater than equals than -6. So you have here x is greater than equals than -6. Okay?
Okay.
Yeah. Same thing for here. You make this less than equal than 0. And then when you do here, if the inner guy is negative, and then if you have the negative of that guy, the inner is a negative. You want to get rid of the guy, so it's negative of negative, which is this. Yeah.
Okay. Thank you.
Everybody, please pay attention. This Algebra 2 AEC, this semester, you guys will learn to check if one function is the inverse of the other by doing composite function f of f inverse. So the thing I'm talking over here, this is a basic foundation. Make sure that guy is x if x is greater than 0. Negative x if x is less than 0. And you say, where would I put 0? You can put here, you can put here. Doesn't matter, both are fine. But you need to know that the inner guy is positive, you just take it out. The inner guy is negative, you have to put a negative. But they won't give you so simple as an x. Always they have something inside. Do some shift, horizontal shift, or horizontal compression or stretch. They want to make students feel confused. You focus on the guy inside here, a whole package, solve it. That is your restriction. And you put two scenarios. One is this, one is this. I like to put blue and purple to make myself organized. That's number 14. If you finished, quickly send me. We still have a lot of work to cover today. Number 16. This one. This one is a bad guy because it has 2 outside and it's not 0 outside either here. So what we do? Let me call Sophia. Let's try here. Wow, Alice, that's pretty good. Okay, let's first moving around. Let's solve this one here. Look, so the inverse function, we want to get the inverse function, the absolute value inverse function. So here, we first do y equals to this, correct?
Mm-hmm.
And to solve the inverse, we will flip. So x to y to x. So far, so good.
Mm-hmm.
Like this. Make sense?
Mm-hmm.
Okay. And then we want to solve the y. Yeah, we want to solve the y. Because after we solve the y, we get our inverse. Yes?
Mm-hmm.
So we are going to move this to this left. So go ahead. If you move this to the left, it becomes
X plus 4 equals -2. Oh.
So I do one step and
Yeah.
make this. So
Yeah.
far, so good.
Mm-hmm.
Okay. I always keep the absolute stuff as the whole package on one side. In that way, I'm going to just discuss this guy only. Okay?
Mm-hmm.
Now, let's do here. We can talk about a different scenario. First, we want to make this guy here a positive. So we make this greater than 0. Yeah?
Mm-hmm.
So if this is greater than 0, then this is who? This becomes
Positive.
y minus 3. Yes?
Yeah.
So y minus 3 equals to -1/2 parentheses x plus 4. Correct?
Mm-hmm.
And then we can solve the y. Yeah? We can move around, but we have this guy solved. Y is greater than or equal than 3, right?
Mm-hmm.
And then we can move around. Let's go. Solve the y equals how much? You can say this can be simplified to who?
-1/2 x minus 2.
Very good. And then our y will be?
Y will be -1/2 x plus 1.
-1/2 x plus 1. So far, so good.
Mm-hmm.
And then we can say over here, this is our restriction for the inverse functions y. So that means if I want to drop down the original one, that's going to be my x. Yeah, you flip x, y. So here, y is greater than or equal than 3. So that means the original one should be greater than or equal than 3. Yes?
Mm-hmm.
So we drop down the inverse guy over here. Make sense?
Mm-hmm.
That's it. Yeah, that guy has this inverse function when you satisfy this part. Okay, and then we will do the other part. Let me call another student. So Audrey Jin, let's do the purple parts. Okay.
Sure.
So we can solve the other piece. Let's go. Just now we did the greater than or equal than 0. So here we will do
So then it changes to
less than, yeah.
less than
Okay.
0, and then it will be y minus 3 will equal to negative parentheses negative x plus 4 divided by 2.
Yeah, so the guy inside is negative. If I want to take off the jacket, I will put a negative, right?
Yes.
So I will have y, see here is x plus 4 divided by -2 equals to negative of y minus 3. Okay, so far so good.
Yes.
And then the both side has a negative. I'm going to make it a positive. Okay, and over here I'm going to make it solve here. Y is less than or equal than 3. Okay?
So then it's y equals to x divided by 2 plus 5.
Yes, so we have here, both are negative, we can cancel it. So y minus 3 is 1/2 of this. And then we can move around. This is 1/2 x plus 2 plus 3, which is plus 5. Yes?
Yes.
That's what's going on. Any questions so far? The guy here, solve this y less than equal than 3 is your inverse function's y. It's the original function's x. So you change this guy to be here. The thing you solve here is the guy for you to apply as a restriction over here. Then you have this. Okay. Any questions so far? If you show this part and show this part, nobody can take off your points. This is exactly following every step that the teacher is asking for. Okay. You solve you switch the y to x, x to y, and then you move everything to the one side. You leave the absolute value stuff by itself. And you talk about this guy in two different scenarios, and then you solve your y. If you stop at here, if you only show that thing and you box it, and if you show that thing and you box it, still sorry, the teacher will take your points because you have to talk about at what situation this guy has this inverse function. You have to show this. You have to show this. Yeah. Because this.
I have a question.
Yes.
For the restricted domains, x, for the ones where you have x is greater than or equal to 3 or less than x is less than or equal to 3, it's because you switch the variables from the inverse. Right?
Yes. The original function's x is the inverse function's y.
Okay.
Because we are doing here. That's why this guy switched to here. That's why this guy switched to here. Okay?
But the y is less than 3 doesn't apply to the inverse function. You just switch it for
Right. This is for you to solve this one into two different scenarios here. And that guy, keep in mind that this is the original function's x. The restricted domain is asking for the original function's domain.
Okay.
That's what's going on. Yeah, they are looking for this. When they are grading your work, they are looking for this.
Okay.
Yeah. This is confusing, right? This is confusing. Any question? So let me check students' work. And number 17, you guys can do it. I'm going to check students' work. I want to see if you did anything wrong, I can correct for you. If you do good, I'm going to praise you, okay? Yeah, Alice is the first student to send me all the correct work with the detailed steps. Every part is correct. Yeah, Audrey Jing, very good. If you can have a darker pen, please use it. It's too light for me to see. Thank you. Any questions so far? Any student say, can you walk through with me? Unmute yourself. Let's show one more example. I work with students together, and then we will move on to the next topic. We have a lot of things to cover today. Any student? Shunlang, are you doing fine here?
Yeah, I'm doing okay.
Okay. Okay, I'm going to talk next topic. So long time ago, you guys did the system linear equations. And in Algebra 2, this guy come back. But when it come back, it's come back in a way more complicated format. We are going to talk about the matrix Gaussian elimination very soon, but not today. But we want to see how can we solve these three variables equations. Okay, look, when they give you this kind of thing to solve, you cannot solve this one directly. You want to treat, because everybody has a reciprocal. So you are going to do this reciprocal for each one of them. So this is your A, this is your B, this is your C. This is your A, this is your B, this is your C. So you are going to solve your A, B, C. So I'm going to let you here. Who want to do this linear equation with me together? Unmute yourself. Let's do it. Anybody? Alice, you want to try? You can do it. Yeah, your math foundation is pretty good. Let's try here. You have three variables. You want to reduce three variables to two variables first. So very soon we are going to learn this thing. Look at here. Yeah, very soon we are going to learn this thing like this. It's called, we are going to do the Gaussian elimination to solve. The Gaussian elimination is based on our foundation right now, okay? Yeah, we are going to do that hard later, not this class. Let's change from 3 to 2. In the future, we solve 5 variables, 5 equations. We always want to reduce from high order to lower order. The reason we learn matrix is going to, in the future, we can solve 100 variables. That's why we have to do programming. But right now, we change 3 to 2 first. Go ahead. What we can do?
You can
Did you see? You want to cancel? Can we cancel A? Doesn't matter. Any variable is fine.
you can cancel B.
Okay, you want to cancel B? Go. What do you do?
On the top, you would times everything by 3.
Yes, go.
And that would be 18A minus 3B plus 6C equals 24.
Good.
And then it would be subtracted by 2A plus 3B minus C equals negative.
So you want to plus this, right? You want to plus, correct?
Yeah.
Okay, let's go.
20A and then plus 5C equals 15.
What do you do next? Look, if I were you, I will immediately do the simplification. In the future, when we do the matrix, it's going to be so easy to do all kinds of careless mistake. My advice is, if you can simplify, do it as early as possible. Go ahead, please.
So it would be 4a plus c equals 3.
Okay. And then what you can do to cancel the other b? Go ahead.
You could times the first one by 2. And
Okay.
add them. So it'd be 12a minus 2b plus 4c equals 16.
Good.
And then you add the other one. So it'll
Yes.
be 16a plus 9c equals 17.
Okay. And then go ahead.
Oh, and you could just times 9, right?
Oh, you can times 9? Sure. Go ahead.
So then it would be 36a plus 9c equals 46.
Okay. Next.
And then you subtract it,
Mm-hmm.
and then it'll be negative 16.
Sure. I will like to do this minus this so that it's
Oh.
quicker. Yes.
It'll be 28 equals 10.
Uh-huh.
10 over 20, which is 1/2.
Good. And then we can plug in. Go ahead. 2 plus c equals 3, right? C equals to 1. Okay. Yeah. C equals 1, right?
Yeah.
And then we can go ahead, put into any of them. Yeah. Which one you want to use?
The second one.
Second one, go.
Wait, so you plug in C and
Uh-huh. This is 2a, which is 1. Yeah.
1 plus 3b minus 1 equals negative 9.
Uh-huh.
And then I just need 3b equals negative 9.
So b will be?
Negative 3.
Yeah. Did we finish everything already?
Yeah.
If it's 2 variables, it's not too much. If it's 3 variables, we take a long time to solve it. We want to plug in back just to make sure. Okay? Just make sure if you have time. And we can skip that step. And we want to solve the xy. So we get the xy will be? Everybody will have the reciprocal, right? So x is who? 1/2 reciprocal is 2, yeah? Y is going to be who? Negative 1/3. And z is going to be 1. Yes?
Yeah.
Uh-huh. Yeah. So look at here. This is 2D. So you have a first line. You have a second line. You have 3 scenarios. If the slope is different, you cross at one point. If the slope are the same, parallel, no solution. If these two overlap, infinite many solution. Okay? But, Alice, what does this mean? This is what kind of line? What do you think? This is for 3 variables. It's each one represent a unique plane. In 3D, each equation has 3 variables. So it's going to be not 2-dimensional anymore. In the previous way, you only have x and y. In the 3 variables, you will have x, y, z. Each equation corresponding to a unique plane. So you are solving the 3 planes crossing point. So there are going to be many different scenarios, because sometimes 3 planes crossing at one point. Sometimes 3 planes are all parallel, no solutions. Sometimes 3 planes could have infinite many solutions. For example, you have everybody can see the camera, right? So you have 3 pages, and they all crossing at this line. Yeah, 3 pages all crossing at this line. So you could have infinite many solutions also. So that's going to be 3D. It's going to be way more complicated. I believe all the students here can do the system linear equation, 3 variables. Yeah. If you have any question, you say, I have trouble to solving this. You stay with me today to make sure you can solve this one quickly, because we are going to learn the Gaussian elimination using the matrix method very soon. Yeah, the foundation is here. Any questions so far? Now, let's talk about another parts. The linear programming. If in Algebra 1, your school already teach you the linear programming, please raise your hand. Let me see. Anybody already learned the linear programming in your school? Good, Sophia. Who else? Anybody learned something like this, linear programming before? Only one student learned it before. Okay. Even though the name sounds complicated, actually it's not hard. It gives you inequalities. It gives you not just one inequality, it gives you 3 or 4 to come into a region. So the first one here, this represents, look, Sophie, you can explain to me what each one represent what. This one means?
That means like it's the x boundary, so the line has to be, well, like the amount has to be greater than 0.
It's over the right, yes. And this one?
That means it has to be greater than 0 on the y-axis.
So this is going to be in quadrant 1, right? Yeah.
Yeah.
Q1 immediately. And then for here, we change this to be this. Yes. This has a intercept of who? Y slope of who?
Slope of -2 and a y-intercept of 6.
So it's going to be this line. Okay. Yeah. 3, 4, 6. So this is -2x plus 6. Yes. Less than equal than, so below this one, right? Below this one. At the same time, we want to be below this one, correct? Yeah. This guy has a slope of a -1/2, y-intercept of 3 of this. So you have below that and below that. The common area will be this, right? So they say, hey, that's just an inequality. What does this relate to the linear programming? You use this to find your region's vertices point. After you find this vertices point, you are going to apply the whatever they give you, like the profit or the minimum time to plug in. So this is the first step by figuring out the region. After you figure out the region, you have the corners. You write down all your corners. They can ask you this and draw the graph. They can also give you a graph and ask you those inequalities. So for here, the x is going to be bounded between 0 and 6. And for here, the y is bounded between 0 and 5. And for that, you find out the slope is -1. This is 2. This is 2. So this is -1. The y-intercept is 0, 2. It's above, so it's greater than equal than. And then you have this to secure this part, and you find out your corners. That's the thing for this question. Same thing for here. You are going to be below this line, so you find out the line. You are going to be bounded between here and here, and you are going to be above 0. So that's those inequalities. And of course, they check you, oh, is this point agree with everyone? So you will plug in into each of them to check if it's true. This is typical PSAT, SAT, simple questions. We want to jump to the worst problem here. So this example showing you full conditions. This full condition give you full vertices, but they give you a profit, the p value. The p is equals to 2x plus y. The system give you this, and they ask you the maximum and the minimum value of the p. So you are going to check your vertices point. You list your each point x and y value, and then you will plug in to find out your p value. Okay, yeah, this is still not hard yet. For your school, they give you words problem. So they give you some question like this. Number 7. So you want to manipulate. This is a bread, different bread. This is one is that guy, and the other is another. Yeah. So it's a B bread or N bread. So it's talking about between this. I'm going to check our students' foundation for your words problem. Try number 7. See if you can list. You can use X or Y. Doesn't matter. Can you figure out this one by using those inequality and finding out the vertices position? Go ahead, please. Number 7. If you think, teacher, I do need help for the words problem, you can unmute yourself. I will do with you together. Anybody want to do the words problem with me? Just unmute yourself.
Can you explain this one?
Let's read. We learn the words problem by reading, but we don't do 10 times reading. We read one time. We have everything ready. Go ahead, read, please.
Lois makes banana bread and nut bread to sell at bazaar.
Okay, hold on. So it's 2 different bread. One is the banana one. One is the nut one. Okay. Yeah. So that's the information I have from the first sentence. Keep going.
A loaf of banana bread requires 2 cups of flour and 2 eggs.
Hey, hold on. This is the banana bread recipe. So it's 2 cups of flour and 2 eggs. Okay. Yeah. So I have it here. Keep reading.
A loaf of nut bread takes 3 cups of flour and 1 egg.
So for the nut bread, it's 3 cups of flour and 1 egg. So far, so good.
Mm-hmm.
And then
Lois has 12 cups of flour and 8 eggs on hand.
Hold on. This is a restriction. The number of cup flour is limited, and number of eggs is also limited. So the maximum flour cup is 12. The maximum number of egg is 8. Yeah. And you will say, if I make a B number of banana bread and N number of nuts bread, then the total number of cup of flour is going to be who? 2b plus 3n. That's going to be the total number of a cup of flour, correct?
Mm-hmm.
This is less than equals than 12. Yes?
Mm-hmm.
The other one, total number of egg with total number of egg. This is restricted by 8. So far, so good.
Mm-hmm.
So we have this too. And then go read the last sentence.
She makes $2 profit per loaf of banana bread and $3 per loaf of nut bread.
Okay, so the profit is coming from this guy make $2. This guy make $3. So we have 2b plus 3n. Make sense?
Mm-hmm.
Okay. So this is a inequality. You can treat this as your y, this as your x, and you can draw your inequality. And of course, it's going to be greater than equals than 0. You couldn't make a negative bread. So with this, you have your 1, 2, 3, 4 vertices. And you pull these vertices right here to solve your p-value at different location. And then you find out your maximum. Yeah, sometimes 2 points may all make the same maximum, doesn't matter. Then you compare, the maximum is a maximum. Did I explain your question?
Mm-hmm.
Okay, then go ahead, try number 7. The training for the words problem is very useful. It can help you do way more better for the SAT, PSAT, ACT standard test. Any student, if you still feel confused, I do number 7 with you again. If you want to use X, Y, totally fine. Doesn't matter. But if you use X, Y, you need to specify X represent who, Y represent who. Anybody need help? Do quickly for number 7. Alice, you are doing fine?
Oh, yeah.
Is this too easy for you?
No.
Any people need help for number 7? I want you guys to have a habit of drawing your map. This is like you drive on the highway. If you don't study the map before you drive on the highway, it's very dangerous. Because if you turn to the wrong direction, it's going to be messed up. So dangerous. So we want to draw the map before you solve. The question is always talking about two different kinds of stuff. They either make bread or they make cookies, or they do some different animals. Always this kind of question. So they talk about two different stuff. You put their wrong name first. And different stuff needs different material. So you put different materials for each of them at the correct location. So you list here 2 cup flour and 2 eggs for the banana bread. And the 12 cup of, and the other one here is 3 cup flour and 1 egg for the nut bread. So you have here. After here, you will see this next sentence is talking about the restrictions. There's no any baking places that say you can use unlimited amount of flour and unlimited amount of eggs. So it has to be a restriction. You have B number of bread. You will have 2B. You have N numbers of nut bread. You have 3N. This is the total amount of the cup of flour, less than equal than 12. You cannot spend more than this. The other is for the number of egg. Your total number of eggs is 8. So you have 2 times B. This is number of eggs for B bread. This is number of eggs for N bread. So you have that, less than equal than 8. So when you have this, you can solve this. But you also figure out who is the profit function. You can do the profit function. You do this 2 here. You do this 3 here. Different brand names have different profit. Okay? Then you can run this model. With these restrictions, you are bounded into this polygon. The 4 vertices is over here. This is your y, this is your x. If you are not used to the B and N, you can choose x and y. Not a problem at all, as long as you do it correct. You can do x, y, no problem. And then you will have x and y here. And you can solve the 4 points. You figure out the maximum profit. Okay. Any question here? Who finished doing this on your own paper? Send me, please. See, number 8, muffin. They always talking about this. You can make your own questions. Why they are doing this? Running any kind of business has to maximize. Any kind of business want to lower their cost, want to maximize the profit. I believe right now Clemens have those kind of sea lunch, right? Usually, previously, kids at lunchtime can hang out with their friends. Right now, almost impossible. You know what's the reason? Anybody know what's the reason they changed the lunch schedule? Anybody have any idea? Alice, do you know the reason?
Because like people were skipping class.
The major reason is the cost. They want to hire less people to keep the stuff. They want to keep less people to maintain the facility. That's a major reason. Yeah, there are some small reasons. But anything is profit driven. Yeah. So same thing for here. You want to run a baking store. So you want to watch out the thing you spend and want to see what kind of brand names is more profitable, like Apple Store. Yeah, why they each year they make a different iPhone 15, 16. Why they keep changing that? Because they make new different stuff. They make new people to buy it. They can make their profit even higher. Why Amazon change their membership fee often? Also, they want to maximize their profit, but they have some risk. Like Costco, if they increase the membership fee, less people will subscribe. Yeah, but if they reduce the fee, maybe it cannot cover the cost. So they have to do a balance. They must run some mathematical model. It's called optimization. So it's the thing here, we are doing the easiest, simplest mathematical model to do the profit. Like number 8. This one here is talking about the same story. Who want to read this number 8 with me together? Any people? Audrey Huang, let's read this one.
Okay. A tray of corn muffins requires 4 cups of milk and 3 cups of wheat flour.
Hold on. Immediately when I start reading, I will write down the things immediately. I know this is called a muffin, right? So this is, first is corn. So 4 cup milk, 3 cup of flour. I use the first letter, okay? Keep reading.
A tray of bran muffins takes 2 cups milk.
So this is a bran muffin. And this is 2 milk, 3 flour. So far, so good?
Mm-hmm.
So we read up to here. Keep going.
There are 16 cups of milk and 13 cups of wheat flour available.
Okay. So number of milk available is 16. And number of flour available is 15. So far, so good?
Mm-hmm.
If I call the number of this corn muffin to be C, number of bran muffin to be B, so 4C plus 2B will be less than equal than 16, right?
Yes.
And the other one, the 3C plus this 3B is going to be less than equal than 15. So far, so good.
Mm-hmm.
And then the last part, come to the profit part. So the profit will be
3 per corn muffin and 2 per bran muffin.
Yes. So this is our profit function. With this, we have the inequality, and it's going to be in quadrant 1. So we will have something like this. And then we can draw our polygon, figure out the 4 vertices, and run this profit with a table. Okay? Yeah. Go ahead, do number 8. And I'm going to check students' number 7 work. No, nobody sent me the work for number 7 yet. Good job, Audrey Huang. That's pretty good. Very nice work, Lydia. Thank you. I still prefer that when you show the work, you want to list this as a table to show this thing. Showing this table will be more clear and to make you get all the full points. In the future, when you learn the calculus is going to have similar listed table called candidates test. So you want to have a habit now, listing your stuff as a table. In the future, when you do the calculus part, you will also have the same habit to get the full points. So Lydia, please include it in a table. Okay. And Audrey also including a table. Alice, you finish number 7. You can send me also, and also number 8. Thank you, Alice. That's pretty good. Thank you, Lydia. Oh, Sophia, you sent me a file. Thank you. I see that. That's pretty good, Sophia. Very neat work. Okay, this is about linear programming. I show my detailed notes here. There are still several more questions. So for number 9, number 10, and number 11, I show my work. Look, this is always about doing the store on. You either sell that or another things, or tomatoes or green beans. Okay, yeah, it's all similar question. After you do 2 or 3 questions, each question is similar. It's no longer a big problem. Now, let's come back to the inverse. This is the major parts. I need to make sure students can all do this pretty well. Let me also check with this. Did you guys see something like this? Did you guys see this kind of question? For this thing, you want to satisfy the domain and you want to satisfy the range. Sometimes you think it's so hard to make everybody happy. This is the thing here. We do this. X is greater than, equal than -4. So it's going to the right, of course. You don't draw anything on the left. And then you have the y is less than -3. Y is less than -3, and it's a dash line. You cannot include. So you draw this thing, draw here. And then you are greater than 4. You are here. So you are either above this or you are below this. But you are above this and at the same time you cannot equal. So you know that you have to make it open. So if you want to draw that thing, if you want to draw this thing or that thing, you will fail the vertical line test. So the guy cannot go in like that direction. This will fail the function's definition, vertical line test. So you have to have a certain point to split. You either make this part go up or make this part going down. Okay? Yeah. Or you can from here, you can make this part going up, you can make this part going down. Doesn't matter, both are fine. But the key point here is you have to make it equal here. You want to make this open so that you are greater than 4. But you want to make this have a solid dots so that you can make your x as a definition at x equals to -4. And then for same thing for here, you want to open here. You want to make this open. You're going down to satisfy this. But at the same time, you want to make your function has a function at x equals to 0. You don't want to have a open circle here, because inside here, you didn't say x not equal 0. So that's why you put a dots here. You put 2 dots here to solve the problem to make that thing happy and this thing happy. That's how we do this. Let's see number 12. Everybody, go ahead and draw it on your own paper. Give me a picture of your work. See if you can satisfy this. You have to make sure your function are all defined when x is less than or equal than 2. And also, don't make this close. And also satisfy the vertical line test. Number 12, do this on your own paper. If you do very fast, you can do number 12 and also number 13. Next Monday, there is no school. So I on purpose we learn a lot of new stuff today because I want you to study this during the Monday break and then get your quiz and test ready for the future, okay? Because we want to run a heavier school for this Gaussian elimination. This thing takes a while to digest. That's a Gaussian elimination. Alice, the graph you draw in there, so you make the x equals to 0 as a vertical asymptote, correct? Alice? So you might have to draw the line to follow that trend. Otherwise, if you just draw a straight line, the teacher might say, hey, how do you make sure that one doesn't cross that line? You see what I mean?
Yeah.
You want to be careful because the teacher grading very picky, okay? But your graph is correct.
So what do I need to do?
The line you draw there, you want to show in that trend. Because if you draw a straight line, how does you know that this guy will not continue going this way so that it fails the vertical line test?
Okay.
Yeah, because I know that the teachers sometimes they They are very picky. They take out points very easily, okay?
Okay.
Yeah. Okay. So Lydia. Oh yeah, Lydia. That's good. That's good. Lydia, you want to draw the arrow button, the arrows also this direction, because you want to go all the way to the negative infinity, right? Lydia? You want to make that guy go that infinity also. So as long as, see here, this is x equals to 2. That's a vertical line. And you can choose the y-axis, or you can choose any other vertical line as split points. That's fine. And you can make your split line starting here, doesn't matter. Choosing the y-axis as a splitting line is a simple way to do it. And you can make this guy follow this trend. Don't draw a line. If you draw this line, teacher say, hey, how do you secure this one doesn't pass? So you go this trend. At the same time, you have to what? You have to make your x also equals to 2. You can draw a point here, that's fine. But if you draw a point here, that's wrong. In this way, your y is equals 0, which is not this 2. For this part, because you go all the way to negative infinity, so you can draw a straight line, no problem. You can even draw this arrow over here. Audrey, let's talk about the graph you draw. Audrey Huang.
Yes.
The small part here I see is you try to draw this and you try to draw that. This is going to fail the vertical line test here.
Okay.
Yeah. So you want to see, this is a common way to do this question. You first draw a vertical line here. You know you are on the left. And then you are going to make one guy above, one guy below, and also open circle. So you can choose any of the line here. Yeah. So you can choose one here and you can make it going up, but without crossing. Make this as a vertical line, vertical asymptote.
Okay.
And move the guy to the left. Yeah.
Okay.
Yeah.
Thank you.
Yeah. And also be careful. If I don't fill in this 2, still, if I don't have these 2 purple dots, still wrong. Why? Because then I will not have a point on this. Yeah, I will not. But can I make this solid? Can I make this solid? If I make this solid, this will be equal.
Yeah.
If I make this solid, this will be equal. So I cannot make this solid. So I make this open. Make this open. Because here doesn't have equal. When you see that thing doesn't have equal, you know that you will have always a 2 open circle. 2 open circle. And one is going down, one is going up. But you have to satisfy that thing. If you leave like this, you miss the x equals 0. This one doesn't have x not equal 0. So you have to fill in by dots. Okay?
Okay.
Yep. Number 13. Number 13 is also similar. You are greater than equal than 1. So you are greater than equal than 1. So you are on this right. And then on this right, you can choose another line to satisfy this. You can make one part going up, one part going down. But you want to make sure this is open, this is open, and you can feel the point, but you don't feel the point here. If you feel the point here, this is not satisfied. You cannot draw something like this. That's vertical line test fail. Let's quick summarize the thing we learned today. The first important thing is inverse function. We always want to be very careful when we do the inverse function for the absolute value. Make your whole package. First, write down y equals this. Just copy down. And then y to x, x to y. Hey, hold on. Let me ask a student. Shenlang, based on this example, you tell me the procedure that we can get the guy's inverse with the corresponding restriction. Go ahead.
So first you write that well, first you need to like separate the variables on like different sides, I guess.
Yeah, first we switch y to x, x to y, okay? And then we want to make this separate, right? And then what we are going to do after we have this guy separated?
You make two scenarios?
Yes, good. You make two scenarios, and then when this guy is positive, you can get rid of this absolute value. You can make this equals that guy directly, right? That makes sense?
Yeah.
And then you can solve. And if you leave like this, incomplete, you put this guy as an inverse. You change this y to x, which is original x. This is inverse y, which is original x. Okay?
Okay.
And then you treat this as your blue parts. And you do this second part, which is the purple parts. And then you can make it less than equal than 0. And then you solve the other parts. You solve your y. That's your inverse parts here. And then your function is going to equal to original function here. This is your original function's restriction. Yeah. So
yeah, okay.
The major thing here for people to understand is that's your absolute value function. To get the absolute function's inverse, it's not a linear function 1 to 1, 1x corresponding to 1y, so that you can do it very easily. This is same y value corresponding to same x value. So you have to put the restriction so that this guy corresponding to this guy. And you put when x is greater than this value, which is a purple one, which is corresponding to this inverse one. In the future, when we learn the parabola inverse, we will do the same thing. We will do the same thing for the two different scenarios. Okay?
Okay.
Yeah. So this is the first thing. This is what we learned last class. And then we talk about the system linear equation. 3 variables. Reduce 3 to 2 and then solve it quickly. And the last thing we talk about is linear programming. Figuring out the boundaries, draw the graph, get the vertices, list the table, and solve it and compare. That's it. Okay?
Okay.
So here I already upload. Yeah, so Algebra 2 this semester we will also do those kind of look on. This is those complicated stuff. So we want to do a little bit faster now so that we have enough time to take care of those difficult stuff. What kind of else we can learn? We will learn in the future. In the Algebra 1, we learned the factoring. In Algebra 2, AAC, we will do this kind of factoring. You not only have radical but also you will have the I. And your ax squared plus bx plus c, your a is no longer 1 anymore. You have all the scenarios combined together to solve. So we have to do this kind of factoring in the future. Okay, that's for today's class. I can see you next week, still 7 p.m. If you have any question, you can stay with me. Otherwise, you can leave. I will upload the video. That's for today's class. Thanks for joining my class.
Thank you.
Thank you.
Sophia, you have any question?
Yeah. Can you explain like the first question you did, like the inverse one again?
This here?
Yeah.
Do with me together. Say y equals this, right?
Mm-hmm.
And the y change to x change to y. Okay?
Mm.
And then you will, whoever is inside the x value, drop it down. You are going to talk about everything inside this jacket. Make it greater than equal than 0. Make it less than equal than 0. Two different scenarios. And then this guy here, you cover this. When the inner side is positive, you can get rid of this guy directly.
Mm-hmm.
And then your x equals to negative y minus 6. You can solve your y. Okay?
Mm-hmm.
And then you know that you want to put this restriction right here. Okay?
Mm-hmm.
Yeah. And then same thing. This guy restriction you apply for here.
Mm-hmm.
Make sense?
Yeah.